Greetings to everyone. Today I am going to present a very interesting topic from our Unit 3 Electrochemistry called Conductometric Titration. This topic is a part of our engineering chemistry syllabus under DBATU. I am Lalsindi Sania Shakil and let's begin with this. So before looking at conductometric titrations, let's understand the basic concept of conductance. Conductance is the ability of a solution to allow the flow of electric current. It depends on the presence of ions. The more ions present, the higher the conductance. The principle forms the basis of conductometric titrations. So what are conductometric titrations? These are titrations in which the change in conductance of the solution is measured as one solution is added to another. It helps us to determine the endpoint of the titration without using any indicator. This method is especially useful for titrations involving very dilute solutions or colored solutions where indicators are not effective. So the principle is simple. As titration proceeds, the ions in the titration react and get replaced by different ions. These new ions might have higher or lower conductance. By measuring the conductance at each stage, we can plot a graph and determine the exact equivalence point. This change in conductance forms the core principle of this method. So this is the conductometer, a device that measures the electrical conductivity of a substance and to determine its ability to conduct an electric current. This is the manual setup shown. Now let's look at the different types of conductometric titrations. There are mainly 4 types. First is strong acid against strong base. The second is weak acid against weak base. Third is strong acid against weak base. And the last is weak acid against weak base. Let's understand each of them with examples. So the first, strong acid against strong base. In this reaction, for example, HCl against NaOH, that is hydrogen chloride against sodium hydroxide, initially H plus ions dominate and give high conductance. As NaOH is added, H plus ions are replaced by Na plus ions which have lower mobility, as shown in the reaction. So conductance decreases until the equivalence point. After that, excess OH minus ions increase conductance again. The graph shows a V-shaped curve. This is the graph of strong acid against strong base. For this example, that shows the V-shaped curve. The second is weak acid against strong base. For example, acetic acid against sodium hydroxide. Here, the conductance starts low because acetic acid is a weak electrolyte. As NaOH is added, weakly conducting acetic acid is neutralized and replaced by strongly conducting acetic ions and Na+. So conductance increases steadily and more sharply the equivalence point due to OH minus. Here is the graph representation of this example. The strong acid against weak base, for example, HCl against ammonium hydroxide. HCl provides high initial conductance. As NH4OH is added to H plus ions are neutralized to form NH4 plus, which has low mobility. So conductance falls. After the equivalence point, there is little increase because NH4 is added and ionizes less. Beyond the endpoint, further addition of weakly ionized NH4OH will not cause any appreciable change in conductance. As said, the point of intersection of these curves is the endpoint of titration. The last is weak acid against weak base. For example, acetic acid against ammonium hydroxide. In this titration, conductance initially increases because of formation of salt acid, ammonium acetate, which is strongly electrolyte. This increase as shown in graph, this increase continues till endpoint. Beyond endpoint, the conductance does not change appreciably. The graph is shown as shown in the graph. Advantages of conductometric titrations. It offers several advantages. Let us see one by one. Small quantity of solution is required for titrations, and as endpoint is determined graphically, no special precautions are necessary. Indicator is not required, so conductometric titrations are used in titration of colored and turbid solutions. Conductometric titrations are used for analysis of dilute solutions as well as for weak acids. Conductometric titrations can be applied to mixtures of acids, precipitation and other types of titrations. Conductometric conductometric measurements give more accurate results and computerized easily. So that's for today. Thank you for watching this video.